We can now look at this question here. This is the question which we are going to do today in chemistry. Remember, we've been doing more of questions that involve calculations, but we also have questions that are qualitative, where we just need to understand the chemistry. Okay? So today's question is, we are saying, the following diagrams show two forms of carbon, P and Q. So we have carbon which appears in this form like a tetrahedron. Do we know what a tetrahedron is?
Yes.
What's a tetrahedron from grade 4? A pyramid whose sides are what? Are triangles. It's called a tetrahedron. Are we together? We know what a pyramid is. So now, this one which looks like a pyramid, it's a form of carbon. Are we together? And again, the same carbon, we have this other one now which has some what we call the planes. It's more like a cylinder. It's cylindrical. Are we together? Yes, it's more like a cylinder. Do you know what a cylinder is?
Yes.
So this is cylindrical. It's like a cylinder. Are we together? So even this one, it is also a form of carbon. Are we together? Now, the questions which are there are, the first question, name the allotropes labeled P, which is this one, and the 2 labeled Q, which is this one. Then B, we are saying, explain the meaning of the term allotrope. Then C, what type of bonding is represented by these forms of what? Carbon. Then B1, which allotrope named in A has a physical property which is typical of metals? The last question now is state the physical property after we find it. So we want to do this time. So now, these two are forms of carbon. Are we together? Have you ever heard of diamond?
Yes.
Yes. Diamond is not a metal. No one should lie to you. Diamond is not a metal. It's a non-metal. Okay? It is made up of carbon atoms. Now, in that kind of bonding, you will find that every carbon atom is bonded to 4 others. Have you heard that one? Every carbon, so these are carbon atoms. Have you seen this dot here? It represents a carbon atom. So this is a carbon atom, carbon atom, carbon atom, carbon atom, carbon atom. All these are carbon atoms, in short. Are we together? Now, here we've just cut. This one continues. Even this one is connected to another. So it's supposed to have 4 lines, in short. So each carbon here, like this one, it has 1, 2, 3, 4. So they are all supposed to be 4. So these carbon-carbon bonds are strong bonds. Remember, if we go back to electronic configurations, carbon is C, carbon is C12 and 6, which means this is 2, what? 4. Are we together? So now, if here it is sharing, each line, it means a pair of electrons is being shared. So in this case, here, this line means you have 2 electrons here. Also, this line means you have 2 electrons. Are we together? This also, it's 2 what? Electrons. This one is also 2 electrons. So if you are to calculate here, can we count? 2, 4, 6, 8. So this is a covalent bond whereby every carbon atom is bonded to 4 others. Are we together? So here we have got 1, 2, 3, 4 single covalent bonds. Are we together? Yes. So this is how carbon is bonded when it comes to what? To diamond. Are we together? So all the electrons here participate in bonding. We don't have free electrons here. Now can we look at this other structure? So in this one, P, we are terming it as what? Diamond. Yes. That's the term we have given it. It's diamond. This is diamond. Now this one also. Now with this one, every atom is bonded to 3 others. Are we together? 3. So meaning here we have 2 electrons, and here also 2 electrons. Have you seen that? Now when we count for this one, we have 2, 4, 6. Are we together? So meaning that there is 1 electron which is missing, and also for this one there is 1 electron missing. So it consists of some free electrons which do not take part in bonding when it comes to graphite. Are we together? Now these 2 things which I've mentioned, these 2 properties, where we have got, here we have got 3 bonds, this side we have got 4 bonds. They are all covalent bonds. This one which has 4 bonds is very strong. Are we together? Because we have no free electrons. But here where we have some free electrons, this bond becomes weak. That's why now when you compare this form of carbon and this one, you find that the one which is diamond here is very strong. It's a strong bond because there are no free electrons. Here where we have free electrons, it is what? It's a weak bond. I'm mentioning of free electrons because normal, we are supposed to have 80, if at all it is 2. Because this has what? This one has got how many? 4 in the outermost shell. Also this other one has 4. But if you have 2, 4, 6, where are those 2? Because if you count for this one, you're finding 2, 4, 6, 8. All the 8 electrons are participating in bonding. But in this case, 2, 4, 6. Where are the other 2? Those are free electrons. They are able to move around this what? Substance. So this form of carbon, which is more like a cylinder, this one is known as graphite. This is graphite. Okay? This one, I'm sure, this one is not common, diamond. This one is mined, it's not common, eh? Yes, but at least somewhere we have seen diamond before. Maybe either a ring or whatsoever, but we've seen diamond before. Are we together? Now this one, graphite, this one is common. Your pencil is made up of graphite. That's one example. This, give me your pencil. Give me your pencil. Have you seen this black substance here? This is graphite. It's made up of graphite, this substance here. Are we together? So it's soft. Graphite is soft when compared to diamond. Are we together? Another good example of graphite is charcoal. Okay? Charcoal is graphite. Are we together? Yes. Apart from charcoal, I don't know if you have seen those cells before. Those cells, the batteries, that's the common name. Batteries, the cells. Where you find positive and negative, something like that. Those cells, if you break it, you'll find there will be a substance. There will be a substance which looks like chalk. You'll find a black substance which looks like chalk. I don't know if you have ever seen it. If you break a cell, those ones, the batteries, the energizer, talk of tiger, whatever, those batteries. If you cut the battery, you find that there is a black substance there. That substance is made up of what? Graphite. Are we together? So that is also an example of graphite. So I'm sure you have answered this part. Is it okay? Yes. Have you seen seen these lines? Each line, it means 2 electrons are there, isn't it? Then remember, we said for carbon, maybe, let me write it this way. This is a carbon bonding with another carbon. That's what we are saying. Now, each line, when we draw a line, it means 2 electrons. One from this and one from the other. What of this side, again, we connect it to a carbon, isn't it? There will be also 2 electrons. One from this one from the other. Again, this side, 2 electrons. You've seen that? One from this one and one from the other. Same applies to this side. 2 electrons. So we want to consider that one. Now, this carbon here, it has how many electrons in the outermost shell? Carbon, it's C, 12, and 6. So it's 2, 4. Meaning we have 2 electrons for each, 4 electrons for each carbon in the outermost shell. You get it, huh? So one of, let's say we are considering this carbon here. 1 electron is shared this side. You've seen that? We count. 1 is shared this side, so we have 1 here. Again, the other one is shared here, 2. Another one is shared this side, 3. Another one is shared down, 4. You've seen that? So meaning, since when it shares, it has to receive also the other side. So it will be now 2, 4, 6, 8. Meaning we have a strong covalent bond here. That is for diamond. In the same way, I'm going to present now graphite. In the same way, I'm going to present graphite. We say we have a carbon. Now for graphite, each carbon it has how many lines? 3. So we have this one connected to this carbon, this one connected to this one, and this connected downwards. Now, electrons which are taking part in bonding. Check. Here, 2 electrons, 2 electrons, 2 electrons. Now, when we want to consider this, we'll say, okay, since there are 4 electrons in the outermost shell, right? One is taking part in bonding this side, 1. The other one is taking part in bonding here, 2. Another one is taking part in bonding this side, 3. Where is the 4th one? So the 4th one is what creates now, that's where we have now we have a free electron. Are we together? So same applies even to these others. They all have at least one, there will be 1 electron which will not be taking part in what? In bonding. Now those electrons are very important. They are the ones now which give the characteristic of what? Of graphite, which makes it behave like a what? Like a metal. Because if there are free electrons, then the moment you bring a conductor, electrons would want to flow through that same conductor. So that's why graphite now conducts electricity. Carbon is the only non-metal which conducts electricity. Have you heard that one? So it's only carbon which conducts electricity. Carbon is a good conductor of electricity. A very good example. Talk about electrolysis of water. Those electrodes are made up of carbon. I'm sure we did that in grade 9. And also the one I'm talking about for the cells. That black substance which you find in the middle of a cell, which looks like chalk, but it's black. That one is made up of carbon, which is graphite. So there it is used as a conductor. When you cut that cell, you will not find any wire there. No. You just find this substance there, which is graphite. So it is used as a conductor because it has free what? Electrons. The form of carbon, which is used as a conductor, it is what? It's graphite because it has free electrons. Diamond does not conduct electricity. Why? There are no free electrons. But it has got other uses now, which graphite can't. Are we together? I'm going to talk about the uses of diamond first. So diamond is very important. It is used, one, in the making of what? Cutting discs. Discs, like those for the grinder, whatever, those discs which they use to cut metals, they use diamond. Have you ever heard of, or have you ever seen a drilling machine? Yes. Even those drilling machines, there, down there, the part which drills, it is made up of what? Diamond. Because it's very strong. Are we together? Yes. Yes. So, another use of diamond, making of what? What of the rings? Yes, all those. You can include that as use of diamond. Then graphite. Graphite, because it is soft, one, it is used as a lubricant to reduce what? Friction. Most of these, you find that the bearings are made up of graphite. Why? Because it's soft. So to reduce friction, they will put graphite. Apart from that, graphite again here it's used as a what? As a conductor, as an electrode. So graphite is used as a conductor because it conducts what? Electricity. So, and it's a good electrode, so to say. An electrode is just a substance which conducts what? Electricity there. So I think in summary we have answered everything. So here where we say which allotrope named in A has a physical property which is typical of a metal. So it's graphite. Why? Because the property we are talking about is graphite, and only the metals conduct what? Electricity. But graphite is not a metal, but now it conducts electricity. So it has a property of what? Metals. Have you heard that one? Good. Now, we've talked about this. So now an element, in summary, an element which has two or more forms. Are we together? An element with two or more forms without changing the physical state. That element exhibits what we call polymorphism or allotropism. Okay? Polymorphism or allotropism. Polymorphism. Polymorphism or allotropism. That's what allotropism. So it's polymorphism or allotropism. Now, let me summarize this way. Now, these two forms, okay, of carbon, each is called an allotrope. So the forms themselves are called what? Allotropes. But the existence of allotropes, that is what we are terming as allotropism or polymorphism. You can now ask. An allotrope, a polymer. Okay. Yes, we can term it as a polymer, but normally we reserve that one for organic chemistry. But for now, I think we can stick to allotrope. Yes, unless otherwise. For now, we can stick to allotropes. I know the polymer is coming from from polymorphism. Yes. But for now, I think we let's stick to allotropes. So these are the two allotropes of carbon. What is an allotrope from what I've just said? Yes. You've heard that? So an allotrope is an element that can exist in two or more forms without changing its physical state. Can you write that one?